Hi, this is Mrs. Tellas. We're going to be going over section 1.3, which is solving multi-step equations with variables on both sides. All right, so here are our steps, and we wrote these steps down yesterday when we just solved multi-step equations. We added in, I think, number 3. But the other steps are exactly the same. So you'll distribute first, and you'll combine like terms. And number 3 is our new step where we'll add or subtract a variable term to one side. And I usually take the smaller variable term and go to the bigger one. But there are multiple ways to do these equations. And then add or subtract your constant to one side, multiply or divide the coefficient, and then check the solution. So these steps are the same except for number 3. If you want to pause it and write these down in your notebook, that's a great idea. If not, that's okay too. All right, so if we start our first one, notice that different from yesterday, it's got an x on both sides of the equation. So if we want to get the x by itself, I'm going to move this x over here since there's only one constant. So I'm going to add 4x to both sides of the equation. Over here, the 10 is going to drop. The x's cancel on the left. And this is negative 5x. And then we would divide both sides by negative 5. And we would get negative 2 as our answer. And just like yesterday, you can check to make sure these are right. So 10 minus 4 times negative 2 equals 9 times negative 2. And if you use your calculator or just do it mentally, that's going to be 18 on both sides. All right, let's try another one. All right, so number 2 has a fraction on the right, and it's got parentheses, which is different than the last one. So we need to distribute on both sides. So we're going to distribute the 3 to both of the terms inside the quantity here. So 9x minus 12. And on this side, we're going to distribute the 1/4, or you can divide by 4 on both of them if that's easier for you. So 1/4 of 32, you could either type in your calculator or just do a little division in your head, 34 divided by 2. And then 56 divided by 4, let's see, I believe that's 14. Okay, so I've gotten rid of the parentheses by doing distributive. So now I'm going to take the smaller x term, which is 8x, and I'm going to subtract it on both sides. Now I like to do the smaller one just because it keeps it positive. But that's an option. You don't have to start with the variable, and you don't have to do the smaller one. There's, 3 or 4 ways you could do this. And then I'm going to add 12 to both sides. And then 1x is the same as just x. So the answer here is x equals 26. And again, I could plug it in and use my calculator and make sure it's right. So on your assessment, you want to be checking all of them to make sure that they're right. All right, number 3. Okay, number 3 is similar to number 1. It's only got one constant in it. So I'm going to move that constant. I'm going to move this variable over here to get all the variables on one side and to keep the constant on the right. So here I'm going to subtract 3x on both sides. That's negative 5x equals 10. And I'm dividing both sides by negative 5. X is negative 2. Number 4 is very similar to what we did on number 3. You're going to distribute and then move. Number 5 is also very similar to number 3. Actually, let's go back and do number 5 since it's our last one. Okay, so again, we're going to distribute for both of them. So negative 3/4 times 8. So you can either put this in your calculator, or 3 times 8 is 24. 24 divided by 4 would be negative 6. And I'm going to go over here. I can move down. Negative 6n. And then 3 times 12 is 36. Divided by 4 is 9. And it's negative. And then on this side, 3n minus 9. So I'm going to add 6n to both sides to try to isolate the variables to one side. And then I'm going to add 9 to both sides. So on the left, that gives me 0. Then I'm dividing 9, and my answer is 0. Okay, because 0 divided by 9 is 0. So if I put 0 back in here, that should make a true statement. Or you could check that with your calculator. All right, so because there are variables on both sides, sometimes the variables cancel, and all you have left are constants. So if it makes a true statement, then you would write infinitely many solutions as your solution. So for example, if the variables cancel on both sides and you finish with 3 equals 3, well, that's true. So your answer is infinitely many. And if it makes a false statement when the variables cancel, like 1 equals 4, well, that's not true. It's a false statement. So you would write no solution as your answer. So let's try a couple. So on this one, I need to distribute the 3 to both of them. 15x plus 6 equals 15x. Again, since there's only one constant, I'm going to move this 15x to the other side to isolate the variables. And then there's nothing over here because both of these cancel. So it's just a 0. Well, 6 does not equal 0. That is a false statement. So the answer is no solution, which means there is no number that you can put in here for x to make this true. Okay, so let's try number 7. So negative 2 times 4y would be negative 8y. Negative 2 times positive 1 is negative 2. Okay, and you can kind of already see that they are matching exactly. So, but it's more clear if I get rid of the variable. So if they both go away and I drop the constants, I have negative 2 equals negative 2. Well, that's true. And since it's true, this is infinitely many solutions. And you can kind of see it here in this step when they're exactly the same. I still like to get rid of the variables just because I think it's easier to see with just the constants. Let's go ahead and do, kind of like number 9 because it's got the fraction. Let's do number 9. And it's got 2 m's over here. So see how it has 2 m's over here? So we would need to combine like terms on that side, which is something that we haven't done yet in these problems. So 6m minus 1m is 5m. And then we need to distribute on this side. So 6 times 6m, we'll see 5 times 6 is 30, and 30 divided by 6 is 5. And then 5 times negative 10 is negative 10. Whoops. Let's fix that. And that's a 50. Looks funny. There we go. All right, now because there's only one constant, I'm going to subtract this 5m to this side. And those cancel, which is 0. And that's negative 50 because those canceled. That just dropped. This is no solution. So the only time it can be no solution or infinitely many is when the variables cancel on both sides. So I always move the variables first because it's easy to tell from the constants if they're the same and make a true statement, which is infinitely many solutions, or if they're different and make a false statement, which is no solution. All right, let's do a story problem. So it says a boat leaves New Orleans and travels upstream on the Mississippi River for 4 hours. The return trip takes only 2.8 hours because the boat travels 3 miles per hour faster downstream due to the current. How far does the boat travel upstream? Well, we're going to set distance upstream equal to distance downstream is what we're going to do. And it tells you that right here. Okay, and we're going to let x be the speed of the boat traveling. Okay, so the speed going upstream on the Mississippi River is 4x. And on the way back, let's see, it's 3 miles per hour faster, and it takes 2.8 hours total. So it's going to be x plus 3, and then the 2.8 is going to be out front. So your hours is going up front, and then how much faster it is goes inside with the speed because it's 3 miles per hour faster. All right, so now we just solve. So let's send that through. So 2.8x plus, let's see what 2.8 times 3 is. It's 8.4. So we would subtract 2.8x. So 4 minus 2.8, I'm going to go over here because I'm out of room there. 1.2x. And I'm dividing 1.2. And I should get 4. Let's make sure though. 8.4 divided by 1.2. Oh no, that's 7, not 4. I don't know, I was thinking 7. And 7's your answer. How far did the boat travel upstream? This is 7 miles. And I know it's miles because it says miles per hour faster right there. Okay, so now I'm going to give you another one, and I want you to try it and see what you come up with. I want you to pause it, read it, and give it a try. Remember, you're going to do upstream equal to downstream. Okay, and we're going to do it just like that. So pause it and give it a try. All right, so here we go. If you've already done that, let's check it out and see if you did it correctly. So it says we travel upstream for 3.5 miles. So my upstream is 3.5x. If you did that, good job. Give yourself a pat on the back. Okay, and then it says the return trip only takes 2.5 hours because the boat travels 2 miles per hour faster. So it's very similar to the last one. So we're going to put the x plus 2 because that's how much much faster it went because of the current. And that 2.5 is going to go on the outside like that. And then we distribute again. And subtract. And looks like x equals 5 or 5 miles. So if you got that right, give yourself a big pat on the back. These are probably the most tricky in this particular section. All right, we're all done.